For most of human history, seeing a comet in the sky meant one thing: something catastrophic was coming. It was stitched into the Bayeux Tapestry as a warning of conquest, and ancient civilizations saw these streaks of light as literal omens of death. But today, the evidence suggests the exact opposite. These glowing visitors might actually be the reason you are alive to see them. Far from being just dirty snowballs, comets are ancient chemical payloads sitting in deep freeze billions of miles away in the dark expanse of the Oort Cloud. They hold the raw materials of the early solar system: water, carbon, and complex organic molecules. Most stay out there forever, but when a gravitational nudge sends one falling toward the sun, it becomes a delivery mechanism. Early Earth was a dry, molten rock. Yet we now have growing evidence that violent, high-speed impacts from these exact objects crashed into our planet, seeding it with the oceans and chemistry required to life. You don't see a comet because it's burning. You see it because it's bleeding into space. As it plunges toward the sun, the frozen core sublimates, violently turning from solid to gas. It leaves two distinct trails of debris: a bright white dust tail arcing along its path, and a glowing blue ion tail blown perfectly outward by the solar wind. That tail isn't just a light show. It is a trail of the exact building blocks that made us. For a long time, this was just an educated guess. But in 2014, the Rosetta mission chased down Comet 67P and dropped a lander right onto its surface. And as you might guess, we didn't find a smooth ball of ice. We found a jagged, chaotic world, blacker than coal, venting ancient gases into the void. For the first time, we touched a relic from the dawn of our solar system, proving that the organic compounds necessary for life were right there in the dirt. These objects hold the keys to our origin, yet they remain as dangerous as ever. Swift-Tuttle is 26 kilometers wide, more than twice the size of the impactor that wiped out the dinosaurs, and it crosses Earth's orbit every 133 years, and moving at 150,000 miles per hour. At that speed, the impact energy isn't measured in explosions, it's measured in extinction events. We do have some time with this comet. Astronomers have calculated Swift-Tuttle will return in 2126, and its orbit is currently stable. But a slight gravitational nudge from Jupiter, a fraction of a degree of drift, changes the math for everyone on this planet. Every August, when you watch the Perseid Meteor shower, you are actually watching the debris trail Swift-Tuttle leaves behind. It's a reminder that the most beautiful thing in the summer sky is shed from something that could end us.
Links and details on the blog and in the comments. Clear skies and keep looking up.